In this video, we are going to take a look at how to use Excel to create what will amount to be our own customized probability tables for our special discrete random variables. In this video, we're going to look at the binomial random variable. And we're essentially going to create 3 columns of data. The first column will have the sample space, so all the possible values of x. The second one will have the PDF values, and that will give us the probability that our random variable is equal to x. And then the third, as you might expect, the CDF, which will give us the probability that our random variable is less than or equal to x. So the example that we'll be looking at is the binomial random variable where n is equal to 22 and p is equal to 0.6. Both of these are not available in the standard table that comes with our textbook, right? So I just chose values that we couldn't utilize the tables even if we wanted to. And so for this random variable, the sample space goes from 0 to 22. So I would like Excel to generate the sequence of integers from 0 to 22 and put it all in column A, right? Now, I could type that in by hand, but again, if there's a more efficient way to do a problem, why do the tedious work? Let the technology do the tedious work, and we just take advantage of it. So let's look at this first command. And every command that we will enter, we're going to go up to our formula bar, and it starts with an equal sign that pretty much tells Excel to get ready to do some calculation. And then what is the calculation? Well, here the command is sequence, S-E-Q-E-N-C-E, just the word sequence, and then open parentheses. And then it even highlights and says, okay, this is what you need to put in for this function to work. So for the rows, we want 23 rows of values, right? Because it's going to be each possible value of x will be in a different row. So 23. Number of columns. Well, the sequence function is quite powerful. You can create sequences in multiple columns and rows. Well, we just want it all in one column. Let's keep it simple, right? So just put a 1 there, put a comma, and then where does the sequence start? Well, as we said, it starts at 0. And then what is the step? What is the increment? What is the delta? They all mean, okay, what is the difference between the successive values of x? Well, in this case, because these are integer values, consecutive integer values, then the step is 1, right? So sequence, open parentheses, essentially the number of elements in your sample space, how many columns, where does what is the starting value in your sequence, and then what is the step size, and then I'll close it, and then we have to hit enter for Excel to execute this, and there are the possible values of x, right? And I can scroll down and you can see it goes down to 22. All right, so we're good. So that's our sample space. Now to get the PDF, we need another function. So click on the cell that corresponds to or is right next to, or at least is in the same row with the smallest possible value of x. Make sure that that cell is highlighted. Go up to your formula bar and again hit equals. And now the command that you need for the binomial distribution, it's binom period dist, right? So abbreviation for binomial is binom. Abbreviation for distribution is dist, and there's a period between them, open parentheses, and look, so it's expecting 4 inputs, right? So the first one is the number of successes. Well, those are our possible values of x. So I would have to tell Excel to use the data that's in column A, going from A3 down to A25, right? So I like to type it in. I think you can like click and highlight the section in the your spreadsheet that has the data. I just like to type everything by text. So I want this to go from A3 and then colon to 25. And notice it highlights it for me, right? So you could have done the click and drag thing, or again, my preference is just to type everything in by text. And then the number of trials, well, that's our n. So in this case, our n is 22. Type that in. The probability of success, as we said, we're going to use a probability of success of 0.67. And then the next, so comma, and then after that, we enter, do we want the cumulative or do we want the exact? Well, so this is a Boolean option, and there are different ways you could do it. You could think of it as true or false. If I say false, it's going to give me the exact probabilities, which is what I want. And the way I can do that is just by entering 0. So think of it as binary. 0 for no, 1 for yes. So since I want the PDF values here, I will put 0 for the cumulative and then close my parentheses. And then I hit enter, and there it is. So here are the associated probabilities for all the possible values of x. So you can see these are very, very small, right? This is like, 2.5545 times 10 to the negative 11. So these are essentially 0. And then you can see some smaller ones there. And then as you go up, you can see probably the highest probability achieved is this one. So it looks like an x value of 16 is the most likely, and then an x value of 0 is the least likely. But those are the PDF values now for this binomial random variable. So we get it really quickly for each possible values of x, each possible value of x. Next up for the CDF, pretty much the same process, right? I'm going to click on the cell that would be associated with the smallest value of x. So in this case, it would be C3. And again, just for practice, I think you could do some copy and pasting and then changing the inputs, but I'm just going to type it over so you get the kind of repetitive nature. So binom, period, dist, and the same thing. We want the number of trials. Well, our trials are in ranging from A3 to, what was it again? A25. So A25, comma, number of trials is still 22, probability of success is still 0.67, and now we want the cumulative, we want it to be true. So instead of putting a 0, we put a 1, right? So just think of it as true or false. 0 is false, 1 is true. Close that parentheses, hit enter, and there you go. So notice this is the same, but all the other ones now are a little bit different because what Excel is doing, it's doing a cumulative sum of these. So for instance, this right here tells me that this, the probability that this random variable is less than or equal to 11 is this 0.073791134. And then notice what happens as we get to the largest possible value of x. There is our 1 that we would expect, right? So very easy to generate these values. And, so I generated all the possible values of x and the corresponding probabilities and the cumulative probabilities for everything. You don't necessarily have to do that for a specific problem. Like if the problem only is talking about, one, maybe you only needed like 1 through 8 just to answer all the questions, then you could generate just those values. But if you wanted to see the entire distribution, assuming that it's finite, then yes, you could generate a sequence in the way that we did, and then get the probabilities, the exact probabilities, and then your cumulative probabilities. So hopefully you'll find this helpful. Open up Excel, maybe try to replicate what I did here, and then maybe even solve some of the problems that we've done in class by hand using Excel and just see that we get the same values. You could even generate, some of the numbers that are in the table, and you can compare it just to make sure that you're you're getting the correct values. Well, hopefully you found that helpful, and I will see you on the flip side.